Let's take a look at Chapter 2.6, which is finding equations of lines given various bits of information. By now you should be very familiar with the form of the equation y equals mx plus b. We call this form the slope-intercept form of the equation, and the reason we call it that is because it gives us in the value m the slope of the line, or the rise over the run of the line is the slope part of that, and then we also have the b portion, which is the y-intercept part. This is where the line crosses the y-axis. So we're going to take a quick look at how to find equations of lines given different information. For instance, in the first example, we are given the slope and the y-intercept. So here the slope is -7 and the y-intercept is 0.13. Notice that the y-intercept here is given to you as a point. For instance, if we were looking at the graph of this line, it would cross at 13, so we would go up to 13, and this is the point 0.13, down 7 and over 1, and the line looks something. But how do we write the equation of the line is what we're asking. Well, given the form y equals mx plus b, our slope, this is our m. So we can just pattern match. We can pattern match each part of it. So really all we need to find is our m and our b, and we know that m is the slope and b is the y-intercept, and we've got our m right here, and we've got our b right here. That's the actual point on the y-intercept where it crosses, on the y-axis where it crosses. So really all we're doing is just pattern matching. We're saying that y is equal to some value times x plus your b, and in this case our m will be our -7 and our b will be 13. And so that's the equation of the line. Y is equal to -7x plus 13. In the next example, you're given a slope and a point. So in this case we're given that our slope is 5, and we're given a point, 1/2 and 1. But what we don't know here is our b. Once we find out our b, we can then substitute it in, or and then we'll have the equation of our line. So we're going to take the rest of this video to show you two different ways of doing exactly that. The first is kind of a brute force method, I think. It takes the information that you have. Here I have the m, and here I have a point. And in fact, let's do this. Let's make the point a different color, just for giggles. And I'm going to take that information and pattern match it into the y equals mx plus b, substituting my point for the y and the x and my m value for the slope. So let's do that. Let's say that y is, in this case, 1 equals, our slope is 5, and we're going to multiply that by our x value, which is 1/2. And what we don't know here is the value of b. That we have to find that before we can substitute it back into the equation. Well, that's not going to be terribly difficult as long as we know how to multiply and add fractions. In this case, I will solve for b by putting the 5 over 1, multiplying straight across, and getting that 1 will be equal to 5 over 2, and we'll add to that our b. And so now it's just a matter of subtracting 5/2 from both sides. And as a side note, let's see, those will cancel, and b will equal whatever this is. As a side note, I'm going to subtract 1 minus 5/2. So I need to understand 1 with a denominator of 2, and since 1 is any number over itself, what I have is 2 over 2 minus 5 over 2. let's see, I have $2, I owe somebody $5, so really I still owe them 3.5 of a dollar, we'll say. So my b now I know is -3/2. So now I know that b is a -3/2. So I can write my equation now as y equals my slope, which is 5x, and then my b is a -3/2. So I'll go ahead and put -3/2. I can also alternatively put plus a -3/2. And you'll have to do that when you do it in the Khan Academy, but for our purposes, let's just put -3/2. Let's take the same information where we have a slope of 5 and we're given the point of 1/2 and 1, and let's use what's called the point slope form of the equation. And the point slope means when you have exactly that, I have one point there and I'm given the slope here, so I can substitute that information into a form of the linear equation which looks like this: y minus y1 is equal to the slope times x minus x1. And here our y and our x are the generalized x. They're going to be these parts of it. Our y1 here, put a little dot of it, and our x1 here, those are going to contribute to being the b part of it. And of course our m will be m here. So this y and this x are going to eventually go here. This y and this x will generate this b, and our slope will be our slope. So let's give it a shot. Let's see what it looks like, substituting this information into this form of the equation. Okay, so y is our generalized y minus, now this y1 and this x1, they come from a specific point. Usually when I write this equation, I say the generalized y minus a specific y is the slope times the quantity of the generalized x minus the specific x, and these are the specific x and y values here. So our specific y here is 1, so we'll put a 1 there, equals our slope is 5 times that generalized x minus the 1/2 here for our specific x. And here's where it gets really simple. Since we have everything laid out in front of us, all we need to do is simplify and solve, as we have been doing all along. Now all I need to do is add 1 to both sides, add 2/2 to both sides, and I will get that y is 5x minus 5 plus 2 is a minus 3/2. Notice I got my equation at the end of my solving there versus having to solve for a variable and then substitute it back into the equation.